So remember that work is equal to the product of a force and the distance over which the force is applied, and if the force or distance is variable, we must use calculus. And so again, a useful strategy, take a little bit and sum to find the total. So suppose we want to empty a trough, and let's consider two possibilities. How much work do we have to do to empty the trough from the top? That means we have to carry the water up and let it spill over the edge. And maybe we can just poke a hole in the bottom, and in this case the emptying water actually does work. And so we might look at how much work is done emptying the trough from the bottom. And for this we need to use the fact that water has a weight of 9,800 newtons per cubic meter. So suppose the water height is x meters. What we'll do is we'll take this top slice of water and empty it over the top. And so this top slice of water, well, it's a rectangular prism, dx meters thick, and 2 meters long. And importantly, this length does not change, so we can use the actual value of 2 meters. On the other hand, the width changes. At the top, the width is going to be 0.5 meters, but these slabs of water narrow as you get towards the bottom. Since this triangle has a base equal to its height, then the base is going to be the same as a height, x. So our slab is x meters wide, which means that the volume of this rectangular slab is 2x dx. And since water has a weight of 9,800 newtons per cubic meter, then the weight will be 2x times 9,800 dx. Now, if we want to empty this out of the top, then we need to lift this to the top. And since the trough itself is 0.5 meters deep, to get this slab of water to the top, it will have to be lifted 0.5 minus x meters. And so the work done is force, 2x times 9,800 dx, times distance, 0.5 minus x meters, summed up over that depth between 0 and 0.5. And now we have an integral, we can evaluate it, which gives us the amount of work done. On the other hand, if we allow the trough to drain, if the water height is x meters, the top slice will still have a weight of 2x 9,800 dx. This time it will be moved x meters, in this case x meters straight down, and so the work done will be force, 2x 9,800 dx, times distance, x, and again we're going to sum these bits of work done between a height of 0 and a height of 0.5 meters. So we'll use integration by parts to get Now we'll throw in a disclaimer. This computation is actually the calculus problem. In the physics problem, we would actually distinguish between two situations. We would do work to empty the trough from the top, but work would be done by water emptying from the bottom. To distinguish between the work done to empty the trough and the work done by emptying the trough, we would use what's known as a sign convention. In this case, when a system does work, we would use a negative sign. And so in a physics class, you would actually make the second answer negative 816.667.